Hi everyone, welcome back to my channel. So today we will be continuing our chapter of kinematics, and in kinematics we have covered the equation of movements and some basic concepts. So today we will be learning about the graphs of kinematics. Okay, so you know that distance time graph and displacement time graphs, how to analyze them, that what is happening in the graph. Okay, we will learn that today. So in kinematics, the first concept that you need to learn is the concept of gradient. Okay, so the concept of gradient is very important. So gradient, what is gradient? Gradient is the slope or steepness of a line, like how steep a line, okay, a particular straight line is. That shows you that what is the gradient, okay, of the line. So if we take an example, okay, I have drawn here. This is the straight line, okay, and you know that how we find out the gradient is rise over run. Okay, so this is rise and this is run. So this gives you, if we divide both them, then we get what gradient. That is why I've written here y upon x. So gradient, there are some points that you need to remember. These are very important points. First point is that gradient of a horizontal line is always 0. Okay, gradient, if a line is like this, there is no slope, okay, there is no inclination, which means that the gradient of the line is 0. Then if a line is fully vertical, straight, okay, it means that is fully inclined at 90-degree, and now its gradient is infinity. Okay, it's very large. You can take it like this, it's 0, then the gradient increase, and then it reaches infinity. Okay, you can grab the concept like this. The gradient of a straight line, okay, straight line means like this. Okay, a line that is straight, okay, has a constant gradient. Okay, its gradient never changes. Then number 4 point is gradient can be positive as well as negative. Okay, for positive the line goes like this, and for negative gradient the line goes like this. Okay, so from the line shape you should get an idea whether the gradient is positive or negative. Okay, so this was the concept of gradient that you must remember when solving the MCQs of graphs. Okay, now moving on to displacement or distance time graphs. Okay, so it could be distance or it could be displacement. Displacement will be applied when there is a negative part of the graph. Okay, we know that displacement vector, so it can be negative. Okay, when it is negative means that the body is moving backwards. Okay, so the first thing that you need to remember is that gradient of distance time graph is speed. Okay, because if we take the gradient of this graph, okay, we have distance on y-axis and time on x-axis. So I'm doing the rise upon run, which gives me speed. Okay, so always remember that distance time graph gives you speed and displacement time graph gives you what? Velocity. Okay, so the first graph, you can see that there is a pink line that is straight. Okay, so if analyze closely, that we can see that the gradient is 0. Okay, so I have told you that gradient of distance time graph is what? Speed. So if this gradient is 0, which means the speed is 0, and what it means that the car or the body is at rest. Okay, the body is not moving. You can see the time is running, but the distance is not going upwards. That is why the car is at rest, okay, at some distance. Similarly, in the second graph, okay, we can see that there's a straight line going upwards. Okay, we have studied in our gradient concept that gradient of a straight line is always what? Constant. So if gradient is constant, then the speed would also be what? Constant. Okay, so there is speed and the body is moving with constant speed. Okay, then we have a curved line. Okay, this is now not a straight line. The gradient is not constant, but now we need to see whether the gradient is increasing or decreasing. Okay, if I draw some straight lines, I can see that the slope is gradually becoming horizontal. So we have studied that horizontal line means that gradient is zero. Okay, so we can analyze from this graph that the gradient is gradually decreasing, okay, becoming to zero. So your speed would also be what? Decreasing. Okay, so I have written here that speed is decreasing. Okay, you can imply same things for your displacement time graph. Okay, just you need to write what the velocity there. These graphs would be same for distance as well as displacement. Then our fourth graph is states what? That the if now I draw straight lines, then we can see that the gradient is approaching infinity. Okay, which means the gradient is what? Gradually increasing now. Okay, so the speed is increasing. How? Non-uniformly. Okay, it is not constant and it is increasing non-uniformly. And we have our fifth graph which shows that there is a curve that is going downwards, okay, and cutting the both axes. Okay, now what does this represent? If we again draw the straight lines, we can see that the gradient is what? Increasing. Okay, it is approaching infinity. We can see that straight line is forming in the end of this, okay, graph. So what does it mean? That gradient is increasing. Second thing is that if you remember, the lines are like moving this one, okay, in this direction, which shows that the gradient is now what? Negative. Okay, so this implies that the gradient is negative and increasing. So in negative, we will use now displacement. Okay, the distance can never be negative. Okay, only displacement can be negative. So this shows that the velocity is increasing but in negative direction, which means that your car is moving in negative backwards and its speed is increasing. Okay, its velocity is increasing gradually. So in next graph, okay, last graph of displacement time, we can see that there is okay, the graph is moving like this. So if I again draw the straight lines, I can see that the gradient is now decreasing, okay, but in what? Negative direction, and which implies that the velocity is decreasing but in negative direction. So your car is moving backwards but it's slowing down. So you can use gradient to imply that. Okay, now moving on to our speed or velocity time graphs. Okay, same thing, that speed time graphs would be only for positive side, whereas velocity time graphs can be on the negative side. Okay, the first graph, okay, and okay, sorry, so first thing that you need to remember is that gradient of speed time graphs gives you what? Acceleration. So we know the acceleration formula is what? Speed upon or velocity upon time. Okay, so if you closely look at the axis, if I take out the rise over run this graph, I would get what? Acceleration. Okay, so we will see how the acceleration is, okay, getting with the graph. Okay, so first graph is very easy. The you can see that the line is here, okay, on the time axis. So which shows that the speed is zero, time is moving forward. Okay, time is running, but the speed is not increasing, and speed is zero, which implies that first thing, that gradient is zero. Okay, if gradient is 0, then your acceleration would also be what? 0. Gradient is directly related to your acceleration. So if, and second thing is that the velocity is already 0, we can see that the speed is okay at 0 origin, so that it already 0, which shows that the car is at rest. Okay, car is not moving. But in second graph, if we look closely, that the gradient is still 0. Okay, gradient is 0, which means acceleration is 0, but the car is moving. Okay, because the velocity is what? Constant. There is some velocity here. Okay, so the car is moving at constant speed. Okay, it is moving at constant speed. So constant speed means there is no change in speed, okay, or velocity, which means acceleration is 0. Then this graph shows that there is a constant. Okay, gradient is what? Constant. If gradient is constant, then acceleration would be what? Constant. And acceleration is constant means that the graph, okay, that the car is moving with constant velocity. Okay, constant change in velocity. So like it's moving like 40, then 60, then 80, that the speed is increasing, but at a constant rate. Okay. Then this graph shows that now we can see that the graph is now negative. So we will use what? Velocity. So gradient is still constant, but we can see that the direction is like this. So it's negative now. The gradient is negative. Okay. So acceleration would be also constant negative. Now negative acceleration, we have another term for that, that is deceleration. Okay. Now the speed of the car is decreasing uniformly. Okay. Now like it is 80, then 60, then 40. So it is decreasing now by minus 20. Okay. So this is the graph of straight line. Okay. Then if we get a graph of curve, speed time graph. So if I draw the lines here, I can see that the gradient is gradually what? Decreasing. Okay. Gradient is decreasing. Similarly, the velocity will be decreasing non-uniform. Okay. So this is the speed time graph for a curve. You can see that the speed is gradually becoming what? Constant. Constant. Okay. We have also studied in O level that this is what your terminal velocity. Okay, if an object is moving in air. Then our last graph which shows that the if I again draw the lines here, I can see that the gradient is gradually increasing to infinity. Okay, which means that acceleration is what? Accelerating. It means it is increasing. Acceleration is increasing. Okay, so your indirectly with your velocity would also be what? Increasing non-uniformly. So these were the graphs of velocity time and distance or displacement time graphs. Okay, there are also acceleration time graph, but they are easy if you get these graphs. Then we have a concept, very easy concept of area under the graph. Okay, area under the which graph? Velocity time graph. Okay, area under the velocity time graph gives you what? Distance, or it could be displacement. Okay, so we just need to find the area. If I have given this, okay, this graph, so what I will do, if first approach is to make, we can see that this is about trapezium. Okay, so we can directly find out the area of trapezium using the formula, or we can divide the shape. Okay, this one is a triangle, this is a rectangle, and this is a triangle. You will add all these areas to find out the total distance. Okay, sometimes the graph is like this. So this would be what? For displacement. Now let's do some MCQs related to what we have studied so far so that we can get an idea. Okay. The first MCQ is this one, which shows that the graph relates the motion of a body falling. Say, okay, this is a y and so what is the correct description of the graph? Y is distance and air resistance is negligible. Y is distance and air resistance is negligible. No, okay, Y could not be distance. First, we can see that there's a curve. Okay, there's a curve only when air resistance is not negligible. Okay, so Y is speed and air resistance not negligible. So D would be the correct answer. We can see from the graph that this is what terminal velocity. Then this question states that a stone is thrown vertically from the top of the cliff. So the second MCQ states that the stone is thrown upwards from a top of a cliff. Okay. If I draw a diagram, this is a cliff and this is stone. After reaching its maximum height, the stone reaches its maximum height and then it falls past the top of the cliff into the sea. Okay, into the sea. This is the sea. The graph shows the vertical velocity stone varies after being thrown, r is magnitude, area for two triangles. What is the height of the cliff top above the sea? So we need to find this height. Okay. So if when the stone reaches its maximum height, its velocity would be what? Zero. Okay, we have studied that. So this point is this. Okay. So I think so this area is your what, or this height is your distance is your s. Similarly, this distance would be what? R. So if I need to find this area, okay, this height, I have to what? R minus S. So this would give me the height of the cliff top above the sea. Okay. Which graph represents the motion of a car that is traveling along a straight road with a uniformly increasing speed? So if speed is increasing uniformly, and the two are acceleration and other two are displacement time graphs. The displacement would not be constant. Okay, this is wrong. Similarly, if the speed is increasing, the graph should be like this. Okay, so this is also not correct. Now, from these two, we can see that they're uniformly increasing, which means what? That acceleration is constant. Okay, there is acceleration, but it is constant. So A would be the correct answer because acceleration is what? Constant. Then a particle is moving in a straight line with a uniform acceleration. Okay, constant acceleration. Which graph represents the motion? This would not be the correct. Okay, this shows that a car is at rest. Okay, car is not at rest. Velocity is not constant. Okay, there is acceleration. And in C or D, okay, D would not be correct because we have the question that acceleration is constant, not increasing. So C would be the correct answer. And in last question is of area under the graph. The diagram shows a velocity time graph, okay, of a car. What is the distance traveled between time t0 and t4? Okay, so we need to find this area under the graph, this whole area. So one approach is to divide the shape into two, okay, shapes like this A A is now a triangle and B is a rectangle. Okay, so A would be half, base is 4, and height, if we calculate height, that is from here to here, that is 10. Okay, so this would be 20. Similarly, in B, we can see that it is 2 height and length and breadth. Okay, so that is 8. So if we combine both, that would be 28. So D would be the correct answer. Okay, so this was for the graphs of kinematics. That is a really important concept, and usually its emphasis comes a lot. Okay, in next we will be doing the projectile and circular motion.